There are four main ways that light interacts with matter: refraction, reflection, scattering, and absorption. This isn't a complete list, but most of the other interactions are rare enough that you probably don't see them unless you're looking really closely for them. Refraction is when light bends as it passes through another material. You may have seen this example of water bending the light coming from this pencil. Because the light coming from the pencil is bending in the water, it looks like the light's coming from somewhere else. I know you've seen reflection before. We see it every time we look in the mirror. Light bounces off. What makes reflection special is that the light bounces off at exactly the same angle that it came into the mirror. That's why we can see our reflection. For every ray of light that left us to the mirror, the angle stayed the same as they reflected off. Almost every surface has a bit of reflection: mirrors, glass, metal, water. You can always follow the light back off the surface to where it came from. That's not true with scattered light. Scattered light goes off in all directions, so it loses most of the information about where the light originally came from. But scattered light is probably the most common version of light that we see. Think about it. When you look at your hand, can you tell where the light came from before it got to your hand? Do you see an image of the original light source? Probably not. The same is true as you look around at the walls, the sky, the floor. We get the light, but not the image. If I add some milk to this water to make it scatter more, we can see the light from the laser, but it's a lot harder to tell where that light came from. The other thing you might have noticed when looking at your hand is that it's a different color than whatever light you have lighting your room. Why is that? Because some of the light got absorbed. Absorption means that the material converts the light energy into some other form of energy, usually heat. But different materials absorb different colors of light differently. So when we see something that's green, it's not the green that's special, it's that the material has absorbed the red and the blue light. These light interactions affect everything we see. But scientists are also developing tools to observe much more from these interactions. If we carefully study the amount of refraction, reflection, scattering, and absorption, we can learn how much oxygen is in your blood, how a wound is healing, and even whether or not someone has cancer. If you find that interesting, subscribe or check out this other video I did on diffraction.